right, let's dive right into this explainer and uncover a kind of hidden world that actually protects us every single day. Have you ever wondered why a massive new highway or a giant mining project doesn't completely deafen the surrounding neighborhoods? Or why it doesn't just rattle nearby buildings to the ground? Well, it's not by accident. It is entirely thanks to the highly regulated, deeply mathematical science of environmental impact assessments, or EIAs. Today, we're going to explore the precise science of noise and vibration in EIAs and see exactly how this invisible acoustic shield is engineered to protect our communities, our historic monuments, and our everyday peace and quiet. Here's the roadmap for today. We're looking at the expert detective, establishing baseline evidence, managing the blasting threat, forensic modeling, the acoustic defense, and finally, airtight compliance. Let's get going. Part 1. The functional area expert, or the acoustic detective. Our journey starts right here. So, before a single shovel even touches the dirt on a new site, the project has to bring in a functional area expert. We usually just call them the FAE. This isn't guesswork, okay? The FAE is an absolute, highly specialized authority. They basically act as an acoustic detective, and they're tasked with predicting exactly how a proposed development will alter the invisible soundscape of an area. Ultimately, they're the ones responsible for authoring the project's official noise and vibration management plan. You can't just be a noise enthusiast to get this gig. Under the Quality Council of India scheme, you need serious credentials. We're talking a bachelor's degree in heavy-duty engineering fields like mining, mechanical, or civil engineering, or a master's in acoustics, physics, geophysics, or statistics. On top of all that, they have to demonstrate absolute proficiency in running incredibly complex predictive modeling software and mathematically designing noise attenuation devices. The FAE basically takes a step-by-step, totally forensic approach to build their case. First, they literally walk the site to find what we call sensitive receptors. Think local schools, hospitals, or residential neighborhoods. Then, they design a rigorous monitoring network to capture continuous data 24/7. And finally, they validate and interpret that data to ensure absolute scientific integrity before moving forward. Moving on to Part 2, collecting baseline noise data. Basically, establishing the acoustic baseline. Right, so before predicting the future, the FAE has to establish the current reality by collecting exhaustive baseline noise data. Why? Because different areas have strict, legally mandated ambient noise limits set by the Central Pollution Control Board. For example, look at silent zones. These are areas within 100 meters of hospitals, schools, or courts. They are legally capped at a strict 50 decibels during the day and a whisper-quiet 40 decibels at night. This baseline data tells the FAE exactly how much room they have to work with before hitting those legal ceilings. To figure out if an area actually meets these limits, the FAE relies heavily on this crucial metric called the LEC. Think about it. Sound fluctuates all the time, right? A dog barking, a truck driving by, a gust of wind. The LEC is a mathematical formula that averages out all those wild spikes and lulls to capture the continuous, equivalent noise level over a specific period of time. It really is the gold standard metric for environmental impact. And if a project brings in heavy transportation, the FAE has to calculate traffic noise too. But they don't just count vehicles out on the highway. They use passenger car units, or PCUs. Because, let's be real, a massive industrial dumper truck doesn't make the same amount of noise as your family sedan. In this system, a standard car is 1.0, a motorcycle is 0.5, but a heavy truck or bus equals 3.0. This ingenious metric allows them to mathematically weigh the true acoustic footprint of the incoming traffic. All right, Part 3. Let's talk about something a bit more intense: vibration and blasting assessment, measuring the tremors. This is a genuinely terrifying thought for local residents. If a huge mining project uses explosives just half a mile down the road, how do you know it's not going to shatter your windows or crack the foundation of your home? Well, the FAE actually has the mathematical formulas and empirical standards to answer that exact question, way before a single fuse is lit. So they split this into two camps. First, you have general vibration. That's the continuous stuff, like tremors from railways, piling, or heavy machinery. But blasting, totally different beast. Blasting creates these intense, impulsive shockwaves. To manage this, the FAE has to calculate the maximum charge per delay. That means they figure out exactly how much explosive can go off in a tiny fraction of a millisecond to make sure the shockwave, which is measured as peak particle velocity, or how fast the ground itself shakes, diffuses completely before it hits your house. Actually, the regulations around vibration are incredibly strict when we're talking about heritage. According to the Ancient Monuments Act, absolutely no blasting, no mining, and no heavy construction is allowed within a 100-meter prohibited zone around protected archaeological monuments. This is literally to ensure that a 1,000-year-old temple doesn't suffer a single crack in its masonry from modern industrial shockwaves. It's a fascinating intersection of ancient history and modern science. Part 4, Impact Prediction and Modeling. Time to simulate the future. With all that baseline evidence locked in, the FA moves on to advanced forensic modeling. Step 1 is quantifying the exact sound power level of every single new piece of heavy equipment coming to the site. They calculate the raw decibel output of heavy rock crushers, the continuous drone of diesel generators, industrial blowers, vertical mills, excavators, the whole shebang. Then, they feed all of that raw data into some really sophisticated predictive software. Programs like SoundPlan or the FHWA traffic noise model. They plug in the baseline environment, add the proposed machinery, and boom, the software generates these things called isopleth contour maps. Think of them kind of like a weather map on the local news, but instead of tracking a rainstorm, they visually track exactly how the new industrial noise is going to travel across the landscape, down to the exact decibel. It is an absolutely incredible piece of technology. Which brings us to Part 5, Mitigation and Management Strategies. Building the acoustic defense. So what happens if those predictive maps show the noise is going to breach legal limits at those sensitive receptors? The FAE has to engineer a solution right into the environmental management plan. And it's all about matching the right control to the specific source. For instance, wrapping a super noisy diesel generator in a specialized acoustic enclosure can slash the noise output by up to 25 decibels. Planting a dense green belt around the entire site boundary absorbs another 5 to 10 decibels. And using those controlled millisecond delays and explosives, that can reduce ground vibration, or PPV, by up to 50%. And finally, Part 6, Regulatory Compliance and Quality Management Systems, or QMS, Airtight Accountability. Because let's face it, all this brilliant math and science means literally nothing without strict accountability. Under the QCI accreditation framework, EIA consultants have to operate under a rigorous quality management system. The foundational principle here is elegantly simple: saying what we do and doing what we say. Practically, this means establishing an unbroken, airtight audit trail for data integrity, from the calibration certificates of the sound meters used out in the field all the way to the final environmental report sitting on a regulator's desk. Before a single shovel even grazes the dirt, the project team has to secure an absolute mountain of statutory approvals to prove they can operate safely. We're talking consent to establish from the State Pollution Control Board. If they're blasting, they need specific permission from the Directorate General of Mine Safety, plus a piezo license just to store the explosives. And if they're anywhere near a regulated heritage site, they need a no-objection certificate from the Archaeological Survey of India. The project is legally bound to the FAE's acoustic plan at every single level. So the next time you're driving past a massive construction site or a bustling industrial zone, and you find yourself wondering why the noise isn't totally deafening or why the ground isn't shaking beneath your feet, remember the acoustic detectives. Remember the continuous baseline monitoring, the predictive software mapping out invisible soundscapes, and the strict regulations working quietly behind the scenes to protect your peace. It really makes you wonder, what other unseen scientific defenses do you think are protecting your neighborhood right now? Something to think about. Thanks for joining me on This Explainer.